Alright, you know we always go to word problems now. So here we go. I can solve real-world problems with absolute value inequalities. Absolute values inequalities are often used to model real-world situations involving a margin of error or tolerance. And tolerance is just the allowable amount of variation. Alright, so here's one. Machine lumber mill cuts boards that are about 3.25 meter long. Alright. It's acceptable for the difference of the value to be 0.02 meters, so 200ths. So we're going to write and solve. We know this. I'm just going to write it. Like, I know the difference between the actual length and 3.25 is less than or equal to 0.02. And that's what it is, right? This is the actual length. And you're not allowed to be this far away from that. So we're done, right? That's really it. So you can set it up twice. You can say, hey, x minus 3.25 is less than 0.02. Or x minus 3.25 is greater than negative 0.02. We add 3.25 here. 3.25, and we get x is less than 3.27. That's as big as it can get, right? We do the same thing here. We add 3.25 here plus 3.25 here. And we get x is greater than 3.23. All right. So as you can see, and it's equal to 2, so we should say equal to. That's the lowest one. 3.23 is less than or equal to x, which is less than or equal to 3.27, and that's the range we can cut this in, which makes sense, right? If my margin error is 0.02, I'm either going to be 0.02 bigger or smaller than that. That's 0.02 smaller, and that's 0.02 bigger. Let's do one more. Cereal box is supposed to weigh 13.08, but it's allowed to vary by 1 ounce. So watch me write, I'll say it as I do it. The actual weight must only be different from 13.8 ounces, alright, by no more than, can be equal to, 1/10. So same type of problem. We say x minus 13.81 is less than or equal to 0.1. And we also say x minus 13.81 is greater than or equal to negative 0.1. Alright, we add this to plus 13.81 plus 13.81. We get x is less than or equal to 13. Oh, where'd I get that one? I shouldn't be putting that one on there. That was the absolute value sign I had in there. Let me take that out on both sides. I saw this as a 1. It's just 13.8. Sorry about that. So x is less than or equal to 13.9. And if I add 13.8 over here plus 13.8, x is greater than or equal to 13.7, which is 1/10 off of 13.8. So we get 13.7 is the smallest, which is less than or equal to x, which is less than or equal to 13.9, and those are our answers. So we get a range of possible acceptable solutions within what we would call a tolerance level. That's it. See you guys soon.